Hey guys, welcome back to Programming with Kotlin and Android. My name is Tensor. Today we're going to be mainly setting up for our next project, which will be a cryptocurrency tracker application. The reason I've chosen a cryptocurrency tracker as our next project is because I want to be able to show you guys various different things. For one, I want to be able to show you guys RxJava. I also want to be able to show you guys Parcelable. I want to be able to demo Dagger, which is dependency injection. I also want to look at retrofit and a few other dependencies. And I want to show you guys how to build an application that will react to the circumstances of the device and how the user actually is using the application. This is a reactive application that will change based on the connectivity of the user to the internet, as well as how the user reacts with the application. To get started with this application, we want to go inside our build.gradle and we want to add the Kotlin kapt plugin. This is a annotation processor that is supported with Kotlin, and it will help us bring in Dagger. We also want to bring in a bunch of dependencies for our application. So we've got a bunch of support libraries that we're bringing in. We're bringing in support version 4, the recycler view, the support design dependency, and the support card view. We're also bringing in OKHTTP3. This is a library that will allow us to actually execute HTTP requests. And we're also bringing in the HTTP logging interceptor. We need to bring in RxJava 2 and RxJava 2 for RxAndroid. And we're bringing in retrofit 2. This will help us deal with JSON data. And the converter JSON for retrofit, as well as the adapter for RxJava 2. Then we're going to bring in Dagger. This is our dependency injector library and the Dagger compiler. And we also want to bring in Onco. And we saw Onco in the last application, but this time we're actually going to be using Onco and Onco Commons. We also want to add a little block to our Android block here, and that is this Android extensions experimental equals true. And this will unlock some of the features that are experimental in Android that Kotlin has access to. Now we can sync our Gradle build by clicking sync now. So I had the wrong version for RxAndroid. Sometimes it lags behind RxJava. The actual version right now is 2.0.1 rather than 2.1.3. So I'll rerun my Gradle.build and it should build out properly. I've opened up the Android manifest, and because this application will be pulling from an API, we need to get the internet permissions from our Android device. We want to add uses permissions, Android permissions, internet, as well as access network state. The internet permission, as we saw in our WebView application, will give us access to the internet, and then the access network state permission will give us access to the network state of the phone or the tablet or whatever device this is installed on. The next thing I want to do is create two packages, one called extensions and the other one called model. So model will hold our currency model, and let's create that right now. And this will be a data class. Our currency model data class will be rather large. You can see here that we have quite a few fields that we want to get. All of them are going to be type string with a question mark because they could potentially be nullable. So all of these things that we're getting in from a piece of JSON data from an API. And when we make our JSON requests, some of these may not come through, and because of that we do need to mark them as being potentially null like this. Also, we're going to mark all of them as string, even though some of them may not actually be string, and that's because the API that we're using passes back all of these as strings. So we have a field for ID, then we have the name, the symbol, the rank, the price in USD, the price in Bitcoin, the daily volume in USD, the market cap in USD, the available supply, the total supply and the max supply, the hour percent change, day percent change, week percent change. We have our last updated price IDR, daily volume IDR, and market cap IDR. Now we're going to augment every single one of the fields inside of this data class with serialized name, in which we put in a string representation of the name of each of these. Each of these string values corresponds with the actual value that we get from the API. Also, we're extending this with Parcelable, and we're annotating this entire block with parcelize. And this is important because we are bringing this all in as JSON, and we want to be able to convert it into data that Kotlin can properly read. There are multiple ways to read in data from an API inside of Android. The first one, and probably the least useful one, is called serializing the data, and that's to directly convert the data into JSON and then input it into the appropriate fields. There's a problem with this because it uses what's called reflection to get the data, and the reflection inside of Android is pretty expensive as far as performance is concerned. The other way to do it would be to basically take the JSON, read it in as a string, and then cut it apart. This is not really the best option though, because we have to manually bring in everything and obviously cut it apart. We can also build out what's called an event bus. Again though, this doesn't really make sense for our specific purposes in this application because event buses tend to be fairly complicated. The alternative is parcelable. Now, parcelable, or parceling, basically is marshalling and unmarshalling Java objects. And this is much more performant than just straight up serializing the Java object. Now, typically in Java, when you're implementing parcelable, you end up having to write a lot of boilerplate. Luckily, with Kotlin, we have this annotation parcelize, which will automatically generate all of the code that we would have had to write otherwise. So not only do we get a performance boost by using this pattern instead of using serialization, it is quite a bit easier for us to do it this way. Alright, so now that we have our model built, we want to start to build out our extension functions, or what are essentially our utility functions. We're going to create these two reified functions, and they essentially just take in a reified generic and then they output anything. And this will allow us to gain some performance on our dependency injection. So we have the class function, which has 1s, and then we have the tag function. Then we have this string safe to long function that we're creating, and this is going to allow us to convert our strings to longs without having to worry about them becoming null, by making use of the toLong or null, and then the Elvis operator, and putting in 0L. Then we're creating a function called long Unix to date, and we're going to use this to convert a lot of the data that we get in from our JSON object into date and time pattern. So we create a value called date, and we set this equal to date. And then we have SDF, which is simple date time format. We pass in our pattern, which is the string, and then the locale, we get the default. So this will ping the phone and get the default time. And then we want to pass back our date in this specific format. We also want to create a function that will trim out trailing zeros, and this is just basically what you'd expect. All it's going to do is look through the strings that we pass to it and take out multiple trailing zeros. And we're doing this just because the API we're using can sometimes pass back a string that has way too many zeros. We just want it to have the appropriate amount of decimal points. I'm also going to implement some extension functions to help us get around depreciated versions. Just get color compact, get drawable. These have to do with the difference in the version numbers of Android versus the newest versions of Android. So if we have Android version M or we have Android version Lollipop, then we're going to be using these better functions. We have this get connectivity manager function. This will just automatically get the system service and then check the connectivity manager. It'll just be easier for us to do it this way. And then we have a function to convert DP into pixels, and we'll make use of this quite a bit inside of our application. Now we want to create some extension functions for our ReactiveX RxJava library. First, we're extending the composite disposable type with this safe dispose function, and this will just cut down some boilerplate and allow us to easily call this .clear. The composite disposable is a type of iterator that we can easily just get rid of and throw out. Then we'll create a function called disposable subscriber. A disposable subscriber in ReactiveX is a subscriber that is asynchronously disposable, and it makes it easy for us to externally cancel this subscriber by implementing disposable. So we have the next, error, and complete methods, which are inside of all subscribers and flowables inside of ReactiveX, and we're putting them in as functions. You can see here one of them uses a generic, passes back a unit, one of them uses a throwable, and the other one has no input value but passes back a unit. And this entire function outputs a disposable subscriber type with a generic inside of it. And then all we're doing here is overriding the onNext, onError, and onComplete methods. OnNext just calls next with the response, onError calls error with E, and then onComplete just calls complete. We're only doing this to basically cut down some of the boilerplate that we would have otherwise. we have two functions on our flowable type. The flowable class implements the reactive streams patterns, and it offers a factory method as well as intermediate operators and the ability to consume reactive data flows. So again, this is mostly about cutting down the boilerplate that we would have to implement. So transform call allows us to just implement these different methods, so observe on, subscribe on, unsubscribe on, and on error resume next on one of our flowables. And then the UI subscribe function allows us to output a transform call, so this function with subscribe with and a disposable subscriber inside of it with on next, on error, and on complete. So these are all higher order functions. They take in functions and then they output other functions. Finally, we want to extend our view and our window. First, we're creating a function called show snackbar, and we're also creating a second function called show snackbar. So a snackbar in Android is a lightweight feedback from an operation. This is essentially just a message that will pop up at the bottom of the screen and basically tell the user that they've done something. And again, we're just cutting back some of the boilerplate here by calling the listener and the show functions and automatically initializing our snackbars with snackbar.length long so that they will stick around longer than usual. Then for our window, we're implementing a method called block touchscreen and unblock touchscreen. And we want this because we want to be able to make it so that our touchscreen is not clickable in certain instances, and we want to be able to remove that attribute when we need to. For instance, if we have a foreground window that pops up in front of the main window, we don't want the user to be able to touch the elements on the main window, so they can just touch the buttons on the foreground window, and that's when we would use this method. And when they do close out of that window and the foreground window now becomes focusable, then the unblock method gets called and it makes it so that we can touch the elements on the main window again. Now let's create our network package. First, inside of our network package, we're going to create a network services file, and this will be an interface. It will have a function called getAllCurrency, which will return a flowable with a list of our cryptocurrency model, and we will basically just call a get method on this route of our API, and this will get all the data that we want for our model. Then we're going to make another class called network utilities. This will take in the context and will create a property called connectivity status, which will be an integer, and its getter method will be a bit complicated. So we get in the connectivity manager by calling context get connectivity manager, and then we want to check to see if we have an active network. So we call on our connectivity manager active network info, and then we check to see if it works through any of these types. So it checks to see if we're on type Wi-Fi, and then it checks to see if we're not on Wi-Fi, it checks to see if we're on mobile. And if it is, then it will check these different subtypes. And then if we are connected to a type mobile and not one of these types, then we're going to return type mobile unknown. If we're not connected to mobile or Wi-Fi, then we're going to return not connected. We'll have another property called isConnected, which will be a Boolean. This will check the connectivity status, which we created up here, and it will check to see if it's equal to type not connected. And we'll create a companion object with a bunch of constant values. And this is so that we can proliferate this information to the rest of our application so that we're not eating through the data of our users. So this is sort of a big deal that a lot of people don't really talk about when building an application. And that's building out an application that just doesn't waste the bandwidth of the users. Finally, we're going to create a class called Crypto Network Service. This will take in our private network services, which is our interface, and then we'll get all of our currencies. This will take in on success, which will be a list of currency model, and will output a unit, so it's actually a function. And then it will also take in on error, which is a function that takes in a throwable and passes back a unit. This get all currency function will pass back a disposable. A disposable is a type that we get from our ReactiveX RxJava library. And as we mentioned before, it's basically disposable data. So a throwable is the error that we get back from the onError function that we're passing into this. And if we get an error back, then we just want to get the disposable and then we want to throw it away. On success, however, we're going to get a list of currency model, which we're going to put inside of a flowable using this UI subscribe extension function that we created earlier. And this is essentially just calling the API, getting all the JSON, then unmarshalling it into Java objects, and then passing it back to our UI as a flowable, which we can then subscribe to and see. Alright guys, I know this tutorial was a bit surface level, but as we get further into ReactiveX and into this application, I will explain it more and more, and hopefully you'll be able to get a better understanding of what this library is and how we're building out our application. If you enjoyed this tutorial, feel free to subscribe and like. If you have any questions or comments, feel free to leave them in the box below. And if you disliked it, then by all means, downvote it as much as you like. Have a good night.